You know that feeling when you're trying to meet up with a friend and you realize it's way faster if you both start walking towards each other? Well, today, we're going to dive into a search algorithm that uses that exact same super clever idea. It's called bidirectional search, and really, it's all about the art of meeting in the middle.
So, let's just start with the most basic question, right? In any complex system, whether it's a map of a city, your social network, or even a level in a video game, what is the absolute fastest way to find a path from point A to point B? You might think the obvious answer is just to start at A and go, but that's often not the most efficient way to do it at all.
Before we get to the really slick solution, we've got to understand the standard approach first. And you can think of this as taking the long way home. These are probably methods you've heard of before, things like breadth first or depth first search.
Okay, so the basic idea here is pretty simple. You start at point A, and you just go. A breadth first search, or BFS, is kind of patient. It checks all its immediate neighbors, then their neighbors, spreading out like ripples in a pond. Depth first search, or DFS, is the opposite. It's impatient. It just picks one path and dives down as deep as it possibly can, only coming back when it hits a dead end. But here's the key. Both of them are a one-way street.
And this is where we hit the big problem, the cost. In computer science, we call this time complexity. And for these standard searches, it's written as OB to the D. Now, B is just how many choices you have at each step, and D is how deep you have to search. But that little d up there is an exponent. That is the villain of our story. It means the amount of work grows exponentially. So for every extra step you take, the problem doesn't just get a little harder. It gets many, many times harder. It gets out of control fast.
So if just plowing straight ahead is going to be way too slow, what's the alternative? Well, it's all about working smarter, not harder. Let's introduce the core idea here with a really simple analogy.
This quote just nails it perfectly. Instead of you having to make the entire trip all the way to your friend's house, what if you both just left at the same time and aimed for somewhere in the middle? I mean, we all intuitively get that this would be way, way faster.
So the plan is as simple as it sounds. You start from your house, your friend starts from theirs, and you meet up in the middle. The result? Well, each of you only has to cover about half the distance. It's such a simple concept, but it has a massive, massive impact on the total effort. All right, so how do we take this really simple idea of two friends meeting up and turn it into an actual working search algorithm? Let's take a look at how it works in action.
Okay, here's the magic. Instead of one search party just pushing forward, we launch two of them. The first one starts at the beginning at our starting node and moves forward like normal. But the second one, it starts at the goal and searches backward toward the start. And the really cool part is they're both running at the exact same time.
So when do we stop? Well, the search is over the very moment those two searches bump into each other. The second node explored by the forward search is also discovered by the backward search. That's it. They shake hands, and boom, we found our path. All we have to do is stitch the two halves together. We don't have to go all the way to the end. And now for the payoff. Why would we go to all this trouble? The reason is a massive, and I mean massive, exponential improvement in performance. This is where it gets really good. Remember our villain, OB? Well, with the bidirectional approach, each search only has to go half the depth, D divided by 2. That means our total work is now 2 times O of B to the power of D over 2. Now I know that might not look like a huge difference on paper, but trust me, when you're dealing with exponents, cutting that number in half is an absolute game changer. Just look at this. The difference is staggering. If a normal one-way search took, let's say, 100 units of effort, the bidirectional search might only take 10. This isn't just a small tweak. We've taken one exponentially huge problem and turned it into two much, much, much smaller ones. It's a whole different league. So if you remember just one thing from all this, let it be this. The number one reason to use bidirectional search is that it massively reduces the time and effort you need to find a solution, period. But of course, there's always a catch, right? Like any really powerful tool, you've got to use it correctly. And it turns out the success of this whole algorithm depends entirely on how you decide to run those two searches.
And this leads us to a really critical question. Is this method always guaranteed to work? Or in computer science terms, is it complete? Will it always find a solution if one exists? And is it optimal? Will it find the best or shortest solution? And the answer to both of those is, well, it depends on how you do it. It really all comes down to this choice.
if you use breadth-first search for both your forward and your backward searches, you are absolutely guaranteed to meet. Why? Because BFS explores layer by layer, expanding out steadily, so an intersection is inevitable. But if you use depth-first search, where each search just dives deep down a single path, they might just blow right past each other and never meet at all.
I love this parallel lanes analogy. Just imagine you and your friend are driving towards each other, but you're on different parallel highways. With depth-first search, it's like you each pick a lane and just floor it. You could easily drive right past each other and never even know it. BFS, on the other hand, is like checking every single lane at every single mile marker. You are going to find each other.
Okay, let's wrap this up. Let's bring it all together. What is the big idea? The main thing you should walk away with today? Here's the whole thing in a nutshell. Bidirectional search splits a problem in two by running a forward search and a backward search at the same time. They meet in the middle, and that saves a huge amount of time, turning one massive exponential problem into two much smaller ones. And remember, for the best, most reliable results, you want to use a method like breadth-first search to guarantee those two paths actually find each other.
And that just leaves us with one final thought. This whole meet-in-the-middle strategy, it isn't just for algorithms, is it? Think about negotiating a deal, or solving a tough puzzle, or even just planning a big project. Where else in your life could you solve a problem faster by starting from both ends? Thanks so much for joining me.